Hello everyone. So myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. In today's video's lecture, I am going to discuss about the two-port network parameters. So in that, we are having the four types of parameters, that is Z parameter, Y parameter, ABCD parameter, and we are having the H parameter. Total four parameters are there. So here in today's lecture, we are going to discuss about the Z parameter. So Z parameter, we can also call it as a impedance parameter or open circuit parameter. Okay. So here, we have to discuss the following things here. So the first point is the introduction of the two-port network parameter and the explanation about the Z parameter, and also we have to discuss the problems on Z parameter. So here, first, what is meant by two-port network parameter? So here, a two-port network is an electrical network model with one pair of input terminals and one pair of output terminals, and it is commonly used to model the voltage and current characteristics of complex electrical network. Okay, so basically so we are having the two-port network like this. So here is the one complex circuit. For this complex circuit, we are having the input terminal and also we are having the output terminal. So here input voltage is V1, I am taking as V1, and the output voltage or the secondary voltage I am taking as V2. And here is the 1 dash, the terminals representation, that is 1 dash, and the secondary side I am taking as 2 dash. Okay, and here we are having the input voltage. If we are having the input voltage and also we are having the input current, so that input current I am taking as I1, and here the secondary voltage is there. So for the secondary voltage I am taking the secondary current I am taking as I2. Okay, so in this circuit the current is flowing like this. So it is starting from 1 2 and 1 dash, and it is leaving here, that is here also I1. For the secondary side also it is a one single loop. So this side also the current is leaving the current. So that current I am taking as I2. Okay. So we are talking about the Z parameter. So here for this Z parameter, so we are having the Z11 and Z12 and Z21, and here is the Z22. Okay. So these are the Z parameters. So here basically we are having the four parameters here: impedance parameter or Z parameter, and second one is admittance parameter or Y parameter, and third one is transmission parameter or ABCD parameter here, and fourth one is the hybrid parameter, that is H parameter. Okay, so here in today's lecture we are going to discuss about the Z parameter or impedance parameter or output parameter, output two-port network parameter, right? So here by using this output two-port network parameter, so we have to find out the input current affect the output voltage. So here it will be analyze the relationship between the voltages and current in two-port networks. So it will be analyze. So here it will be analyze and the relationship between the voltage and current in two-port network, helping to understand the how input current affect the output voltage. Okay. So here we are talking about the Z parameter. So for this Z parameter, so we have to write the equation, that is input voltage and output voltage. So input voltage is V1 and the output voltage is V2. So here how we can write the input voltage? So V1 equal to, so V1 is equal to, so the input current is I1 Z11 plus I2 Z12 is the input voltage equation. And similarly, the output voltage equation is V2 equal to I1 Z21 plus I2 Z22. Okay. So here is the input voltage is V1 and this is the secondary voltage or output voltage is V2. So by using these two equations, we have to calculate Z parameters, that is Z11, Z12, Z21 and Z22. We have to find out the impedance parameters like Z11, Z12, Z21 and Z22 as a matrix form. Okay. So in that case, so what we need to do, first here we have to keep I2 equal to 0. So this is case 1. So in case 1, I am taking I2 is equal to 0. So I2 equal to 0 means it is a open circuit. If current is 0 means we have to open circuit the given element. Okay. So substitute I2 equal to 0 in this equation. So we are having I2 here and I2 here. Substitute in these two equations. So we'll get V1 equal to I1 Z11 plus I2 is 0. So 0 into Z12 is 0. So then Z11 equal to V1 divided by I1 is the first impedance equation. When I2 equal to 0, Z11 equal to V1 divided by I1, and similarly V2. So V2 equal to I1 Z21 plus I2 is 0. So I2 equal to 0 means, so I2 into I2 is 0. So 0 into Z22 value, so 0. So here plus 0. So no need to write here. So then Z21 equal to V2 divided by I1. Here is the second impedance Z21. So here when secondary current is open circuit, the impedance parameters Z11 equal to V1 by I1 and Z21 is equal to V2 divided by I1. Case 1. Now the second case, in case 2, in second case I am taking I1 equal to 0. If you are taking I1 is equal to 0, now we have to open circuit the primary current side. We have to open circuit the primary side. Okay. So now substitute this I1 value again in these two equations. So then we will get V1 equal to, so I1 is there. So I1 value is 0. So 0 into Z11, 0. So remaining term I2 Z12. So V1 equal to I2 Z12, then Z12 equal to V1 divided by I2. Here is the third parameter equation. Z12 equal to V1 divided by I2. And the fourth one, substitute I1 equal to 0 in the secondary equation. Then we'll get V2 equal to, so we'll get the equation I2 Z22, where Z22 equal to V2 divided by I2 is the equation. Here is the 4 parameters. Z11 equal to V1 divided by I1, Z21 equal to V2 by I1, Z12 equal to V1 by I2, Z22 equal to V2 by I2. Now these all 4 equations we have to write in a matrix form. So already we are having the matrix form here. Z11, so Z11, Z12, Z21 and Z22. So where Z11 equal to V1 by I1, Z12 V1 by I2, Z21 V2 by I1 and Z22 is V2 by I2. Here is the matrix form. So this entire equation this Z12 is always equal to Z21. Here is the condition. Z12 equal to Z21 is the condition for the Z parameter. Okay. So this is the total explanation about the Z parameter. Now in this Z parameter, we will discuss the problems on this Z parameter. Right. So here I am taking the one circuit here. So here I am taking the one T network. So this is look like T. Right. So I am taking the T network. In this T network, we have to calculate the Z parameters like Z11, Z12, Z21 and Z22. Okay. So here before that, first here is the we are having the total 4 terminals. 1, 2, this is 3 and 4. We are having the 4 terminals, that is 1, 1 dash and this is 2, 2 dash. Now input voltage is V1, secondary voltage is V2 and the input current is I1 and secondary current is I2. Okay. Now the Z parameter equation. So what is the Z parameter equation? So already we know the Z parameter equation. V1 equal to I1 Z11 plus I2 Z12. Similarly, V2 equal to I1 Z21 plus I2 Z22. So here case 1. So in case 1, so we are taking I2 equal to 0, right? So if I2 value equal to 0, so we are having the equation Z11 equal to V1 by I1 when I2 equal to 0. Similarly, in this case also Z21 equal to V2 by I1 when I2 is equal to 0. Right? By using these equations, we have to calculate the Z parameters like Z11 and Z21. Okay. So in that case, first what we need to do? So here I2 equal to 0. So we have to keep I2 equal to 0 means the secondary current is open circuit. The secondary current is open circuit means this I2 term should be open. Now here redraw the circuit. So here I am redrawing here. So here the element is open circuit and the remaining all the things are same, I1, V1 and this is 12 ohm. So this is open circuit and this is 6 ohm. Now here current in this branch is 0, I2 equal to 0 and this is secondary voltage is V2, primary voltage is V1. Okay. So now by using this network, we need to calculate Z11 and Z21. Okay. So here first what we need to do? So here the input voltage I am taking first. So V1. So here this side there is no element. So 12 ohm and 6 ohm resistors are connected in series. So here directly I am taking here V1 equal to I1 into, so 12 and 6 ohm are connected in series means 12 plus 6. So V1 divided by I1 equal to 18 ohm. So this V1 by I1 is nothing but what? Z11. So first value Z11 equal to V1 by I1, that is 18 ohm. Now we need to calculate Z21. So Z21 is equal to V2 divided by I1. So V2 means, so secondary voltage is there. So secondary voltage means voltage drop at 6 ohm resistor. Right. So here here there is no element means 12 ohm and 6 ohm are connected in series. So series means current is constant here. Then V2 equal to 6 into, so in this branch also current is I1. So V2 is equal to 6 into I1. Then V2 by I1 equal to 6. That is V2 by I1 is equal to Z21. That is equal to Z21, where Z21 is equal to V2 by I1, that equal to 6 ohm. Okay, here is the case 1. Now in second case, so already we are having the Z11 is 18 ohm, Z21 is 6 ohm, right? Now we need to calculate the remaining parameters. Okay, what are the remaining parameters? In that case, first we have to open circuit the primary current. So that is I1 is equal to 0. So that is case 2. So in second case, I1 equal to 0. I1 is equal to 0 means the primary current is open circuited, means the element should be open circuit. So here is the circuit. The primary current is open circuit and the remaining all the elements are same only. So this is V1. Current I1 is equal to 0 and this is I2, and secondary voltage is V2, 1 dash, and this is 2 dash, and the elements are 3 ohm and this is 6 ohm, right? So now if I1 is equal to 0, so if I1 is equal to 0, what is the equation we will get? Z12 equal to V1 by I2. So here Z12 equal to V1 divided by I2 when I1 is equal to 0. And here if I1 equal to 0, we will get Z22, where Z22 equal to V2 divided by I2. So Z22 equal to V2 divided by I2 when I1 equal to 0. Okay. Now simplify the equation. So here first I am taking the secondary voltage. So secondary voltage V2. So V2 is equal to I2 into, so here there is no elements. So there is no element means 3 ohm and 6 ohm are connected in series. So here V2 equal to I2 into 3 plus 6, that equal to I2 into 6 plus 3 is 9. Then V2 by I2 equal to 9 ohm. It is Z22. So where Z22 equal to V2 by I2, that is equal to 9 ohm. And similarly we have to find out the Z12. So where Z12 equal to V1 by I2. So here also same thing. So we have to calculate voltage drop at 6 ohm resistor, and it is a series combination. In series combination, the same current is flowing, that is I2 current is flowing through the 6 ohm resistor. Then V1 is equal to 6 into I2. So V1 is equal to 6 into I2. So here V1 by I2 equal to 6 ohm. So where V1 by I2 is nothing but what? Z12. So Z12 equal to V1 divided by I2, that is equal to 6 ohm. Right? These are the 4 parameters. Now these 4 parameters we have to write in terms of a matrix form. So that is Z11, Z12, Z21 and Z22, that is equal to, so Z11. So what is Z11 value? 18 ohm. So Z12 is 6 ohm and Z21 6 ohm and Z22 is 9 ohm. Now here for this Z parameters, these two are same, means Z12 is equal to Z21. Z12 equal to Z21. If condition is satisfied, here reciprocity is verified. Right? Here is the one problem on the Z parameter. Okay. So thank you one and all.